Hello students. So today we are going to discuss the chapter number 3 in the subject electronic measurements, that is the digital instruments, and this subject it is there for the 4 semester electronic instrumentation and control engineering, and the name of the chapter is digital multimeter. So first we are going to start with the block diagram of digital multimeter here. So as you can see here, the main blocks in the digital multimeters are attenuator, compensated attenuator, current to voltage converter, constant current source, rectifier, analog to digital converter, counter, and display. So first we are going to see what do you mean by a digital multimeter. So a digital multimeter is an instrument which is used to measure two or more electrical values like voltage, current, resistance. It is also it is a standard diagnostic tool for technicians in industries. As I have told, the main blocks in the digital multimeters are attenuator, rectifier, current to voltage converter, current constant current source, analog to digital converter, and display unit. So first we are going to discuss one by one here. Attenuator. So attenuator is used in AC measurements, which reduces the strength of the signal, and the rectifier is used to convert the AC voltage into a DC voltage. Next block is current voltage converter. Current to voltage converter, it is used for the measurement of current. The unknown current is passed through a precision resistor here. The voltage drop across it is measured and displayed. And next block is constant current source. It passes constant current through a resistor. The voltage drop across it is measured and displayed in ohms. And next is analog to digital converter, so that is ADC. So digital multimeter is used to measure analog quantity. So this signal, analog signal, need to be converted into digital quantity, so we use ADC. And last one is display unit. LED or LCD display are used to display the measured quantity. So in this way we have used digital multimeter to measure the electrical parameters like voltage, current, and resistance here. So next we are going to see the digital voltmeter. The digital voltmeter is an instrument which is used to measure voltage between 2 points in electrical or electronic circuit here. The very effective and inexpensive method of analog to digital conversion is successive approximation method. So in this technique we have used the successive approximation resistor technique here. The electronic implementation of SAR, that is successive approximation technique, that is shown in the next slide. The digital to analog converter is used to provide the estimate. So the DAC provides estimate and is compared to the input signal. A shift resistor called SAR, that is successive approximation resistor, is used to control the DAC and the estimates. So we are going to see in detail the functions of each and every block here. As we can see here, the digital voltmeter with digital to analog converter, it contains a successive approximation resistor. It contains a decision logic. It contains input comparator. It contains data output. So as we will see here, so first we are going to start with the input comparator here. And from the diagram itself you can see there are two inputs to the input comparator here. So basically comparator is going to compare the input voltage with the estimate value of D to A converter. As you can see here, the one input is from the input voltage to be measured, and another input is given from the D to A converter. So next, if the input voltage is greater than the estimate value, so then the comparator output goes low, and when the input voltage is less than estimated value, then the comparator output goes high. There are two possibilities here. Comparator output goes high or low. It depends on whether the input voltage is greater or lesser than the estimated value. And next we are going to see what is the function of decision logic here. So if the comparator output is low, then decision logic clock the next state, and the SAR output is next guess. So that is what depending on the output of comparator, either low or high, the decision logic is going to display the two clocks here. So if the comparator output is high, then the digital logic decision logic will clear the last state, and the SAR output is the next guess. So right, and next one is successive approximation register, so that is SAR. So it the basic function of this is it generates the binary pattern with indicated weight, and the SAR is used to control the DAC and the estimates here. And next is digital to analog converter. So the digital to analog converter will convert the SAR output into analog and is provided to comparator, which compares the input voltage until it becomes equal to the estimated voltage here. And we have a data output here. If the input voltage equals the estimated value of that, then the signal is sent to the output for display. So the comparator always it is comparing the input voltage with the estimated value. So whenever both the voltages are same, so then what will happen, this SAR register output, so that is the binary pattern, so that will that will be sent to the data output, and clearly we can measure the input voltage here. So the advantages of the successive approximation are it is what less expensive and it is more effective type here. And next we are going to discuss digital LCR meter. So as we all know, the LCR meter, it is used to measure the resistance, capacitance and inductance. So hence the name, it is called LCR meter here. And you can see the different blocks, that is automatic gain control, 1 kilohertz oscillator, then the component under test, and we have a differential amplifier control switch, the phase locked loop, then VCO, that is voltage controlled oscillator, and we have 4-phase generator and phase sensitive selector, LCR function switch, range switch, digital integrator, and finally we have a display there. So basically the LCR meter is used to measure resistance, capacitance and inductance. So therefore hence it is called the LCR meter here. The desired function can be selected by a 3-way switch. So in this meter, the basic principle is used to measure the voltage across the component and the current passing through the component under test. And last one is the processed voltage and currents are fed up to the digital integrator, so which is connected to the display to provide value of test component directly. And there are certain applications of LCR meter, so that is they are used for testing the components of the LCR, that is inductor, capacitor and resistor, and to measure the values of inductor, capacitor and resistor. And third one is to obtain the characteristics of inductor and capacitor, then to perform the quality analysis of inductor and capacitor, and last one is for finding the matched capacitors and coils and resistors for circuit design. And next we are going to discuss the digital frequency meter. So the main blocks of digital frequency meter are, so first one is the amplifier, and before the amplifier the unknown frequency what we are going to find is given to the amplifier. Then we have a schematic trigger, then start stop gate, and there is what a digital readout. The basically the frequency meter is an instrument that displays the frequency of a periodical electrical signal. The unknown signal or frequency is fed to the amplifier to amplify the signal, and the amplified unknown signal is fed to the schematic trigger. And we know the function of schematic trigger is it is going to convert it into square wave. So the output of the schematic trigger is a train of pulses, we can say, and one pulse for each cycle of the signal. And the trigger output is fed to start stop gate. When this gate is open or when it is start, then the input pulses pass through this gate and fed to the electronic counter, which count the pulses. And when the gate is closed or when the gate is stopped, the input pulses are ceased, means they are stopped, and it stops counting. So in this way the digital readout or the counter will display the number of pulses which passed through it in time interval between start and stop. So the frequency of unknown signal we can find out by using the formula F is equal to capital N divided by small t, whereas N is number of counts displayed on the counter, and T is the time interval between the start and stop of the gate. And next we are going to discuss some of the advantages and disadvantages of digital instrument. As we compare the digital instrument with analog instruments, basically we get more advantages. So we discuss one by one what are the advantages of the digital instrument over the analog instrument here. So digital instruments are more accurate than analog, as we know the output will be in the form of display. Oh, right. Either we can display the output in the LED or LCD, so the output will be more accurate compared to the analog. Then the parallax error is eliminated. Parallax error means, as I told, while observing the pointer in the analog meter, if you won't stand properly, if you move either to the left side or to the right side, you feel the pointer is either move to the left or to the right, so that you cannot read the readings properly. So that is what parallax error. As the digital meters will display the output in the form of display, so there will be no parallax error here. And the digital meters are they are compact compact, and they are lightweight, and we get better resolution. And next one is they have the ability to provide automatic measurements. They are more reliable. They are more their reading speed is more, and the human errors are reduced as compared with the analog instrument. And there will be a less loading effect, and so definitely there will be a less power consumption or requirement. So these are the some of the advantages. And the disadvantages are display is difficult to read when the battery goes low. So as we know, it works mainly on the batteries, and if the battery is not good, if it is not in a good condition, or if the battery is low, then definitely there will be a problem with the display. So then during power fluctuations it can record an error. So that is one more disadvantage. And digital nature is unsuitable for adjusting the tuning circuits. And fourth one is warning during use can change properties leading to errors. Last one is the ADC has a limitation on word length. And next and the last, we are going to see the comparison between analog and digital meter. So first one is the input impedance is low. So that is in low input impedance means it draws or provides more power on the signal here, whereas the digital meter will have high input impedance. And whereas the in analog meters the sensitivity is less, that is low sensitivity, and in case of digital meter we have a better sensitivity. And low accuracy in case of analog meter, whereas we get more accurate results in the digital meter. And in case of analog meter there will be a parallax and human errors, but that is not possible, or that will be less in case of a digital meter. And in analog meter the resolution is low, whereas in digital meter the resolution is high. And last one is there is analog meters are less reliable, whereas the digital meters are more reliable. So thank you.